Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So, while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother. You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure, the more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one.